In September 2022, 7 million miles from Earth, humanity did something unprecedented. We didn't just observe the heavens, we struck them. NASA's DART spacecraft, traveling at 14,000 miles per hour, slammed into a moonlet called Dimorphos. At the time, it was hailed as a historic test of planetary defense, a kinetic impact designed to see if we could nudge a space rock off course. We knew we shortened Dimorphos's orbit around its parent asteroid Didymos by 33 minutes, but a brand new study has revealed something even more profound. We didn't just move a moon, we moved an entire binary system. For the first time in history, a human-made object has measurably altered the path of a celestial body around the sun. How do you move a mountain without touching it? The DART probe hit the smaller moonlet, but the two rocks are locked in a gravitational embrace. Scientists from the University of Illinois examined 6,000 instances of Didymos passing in front of stars to track its position with pinpoint accuracy. They discovered that the impact's recoil, the momentum of all that rocky debris blasting away, acted like a natural rocket engine. This explosive thrust reduced the speed of the larger asteroid Didymos by 11.7 micrometers per second. It sounds tiny, barely 1.7 inches per hour, but in the vast mechanics of the solar system, a tiny nudge today becomes a massive miss tomorrow. We've proven that by hitting the mini-moon, we can steer the giant. DART is a massive leap forward, but it's only one tool in our survival kit. Depending on the rock's makeup, a single hit might not be enough. For carbon-rich asteroids like Bennu, we might need multiple bumps, successive impacts to steer it without shattering it. Other concepts are even more exotic. There's the gravity tractor, a spacecraft that flies alongside an asteroid for years, using nothing but its own gravity to slowly tow the thread away. Or ion beam deflection, using plasma thrusters to gently pressure wash the rock into a new path. And then there's the nuclear option. While blowing up an asteroid creates a risk of lethal fragments, a nuclear detonation near the surface could provide the ultimate emergency shoves. But as the DART team points out, the simplest tech is often the best, provided we have enough warning. Here is the sobering reality. DART was a demonstration, not a standing army. Currently, we have no other DART-like spacecraft sitting in a hangar ready to launch. If a city destroyer like the asteroid YR4 were found to be on a collision course today, we would have no active way to stop it. Our greatest weakness isn't our technology, it's our vision. To save the world, we have to see the threat coming. NASA is currently building the NEO Surveyor, a space telescope designed to find the dark asteroids and comets that reflect almost no light. Because in planetary defense, time is the only resource we can't manufacture. We are the first generation of humans with the power to prevent our own extinction by asteroid. We've proven we can move worlds. Now the race is to find them. The 1.7 inches per hour we added to Didymos's journey is more than just a measurement. It's a declaration. The dinosaurs didn't have a space program. We do. Would you trust a gravity tractor or a kinetic impactor to save Earth? Let us know in the comments and subscribe to stay tuned to the latest in space defense.